Alright, hey everyone, so now I'll be going over January Bronze 2024 Problem 3, Balancing Bacteria. Now this problem can be definitely considered the hardest one out of the three, but yeah, I'll try my best to explain it. So Farmer John has n patches of grass in a line where patch I has a level of bacteria that differs by a sub I from that of healthy grass. For example, if a sub I is equal to -3, then patch I has a level of bacteria 3 lower than normal, and would need exactly 3 additional units of bacteria to raise it to the point where it's healthy. Farmer John wants to ensure every patch of grass is corrected to have a healthy level of bacteria. Conveniently, he owns 2 brands of pesticides. One adds bacteria and the other one removes it. When Farmer John sprays either type of pesticide, he stands on patch N, so the rightmost patch, and selects a power level of L. The sprayer has the most impact on patches near Farmer John, with diminishing effects further away. If Farmer John chooses the pesticide that adds bacteria, then L units of bacteria will be added to patch N, L minus units to patch N minus 1, L minus 2 units to patch N minus 2, and so on. This means that patches 1 to N minus L will receive no bacteria since the sprayer isn't powerful enough. So you have to find the minimum number of times Farmer John has to apply his sprayer, so that every patch of grass has the recommended number of bacteria. It is guaranteed that the answer is at most 10 to the 9th. So the first line of input contains an integer n, which means the number of patches that Farmer John has. And then the second line, they give you n integers, and that is the number of bacteria for each patch of grass. So the output, you have to output the minimum number of applications or moves necessary to make every patch of grass have the recommended value of bacteria. Okay, let's draw some test cases and see if that will help us. So if we have -3, 2, 5, -7, 1, and us right here, n is equal to 5, then our goal is to make all the numbers, so all the bacterias, become 0, 0, 0, 0, 0. So we have to try to zero everything out. And how do we do this? Well, we have different powers of pesticides. So L is equal to 1, it could be equal to 2, it could be equal to 3, it could be equal to 4, and 5. Farmer John will always spray in patch N, so that's this patch. If L is equal to 1, then there's only one move he can do, plus or minus 1 bacteria in this patch. If it's 2, he can do a plus or minus 1 here and a plus or minus 2 here. If it's 3, then it's 1, 2, 3, then 1, 2, 3, 4. And notice the diminishing effect. So since Farmer John's always spraying in this column, all the other columns away, so away from where he sprays it, will begin to decrease. So first it's 4, then it's 3, then it's 2, then it's 1. And that's the number of bacteria that gets added. Okay, so for 5, we'll get 1, 2, 3, 4, 5. Okay, so since our goal is to zero all the bacteria out, let's try just working through it brute force way. So if we want to first do something to this patch, then we can subtract 1 from it. If we subtract 1, we have to select, we have to select L is equal to 1, because that means that we'll have a power of 1. So if we select L is equal to 1, we can subtract 1, we'll get -3, 2, 5, -7, and 0. Okay, that's good. We're one step closer to all zeros. Okay, next we have to do something to this patch. And how do we do that? Well, we can select L is equal to 2. And then we can add 7 to this patch. So we'll get -3, 2, 5, 0. But then for this patch, since we add 7 here, we're going to have to add 14 here. So we'll get 14 here. But that's so counterproductive. It's like if there's a leaking pipe and you try patching it up, but then all of a sudden there's another leak that bursts. So as soon as we patch the bacteria over here, we get more over here, and that's not what we need. So now it seems like it's going to be a headache to kind of manage all the bacteria in every single patch. So what's one way we can overcome this? Well, I think if we work backwards, so starting from the first patch and then moving this way, it'll be a lot easier. So this is because we know what we have to end in. We know we have to end in 0, 0, 0, 0, 0. Okay, so that's going to be our final state. So now what's our second to last state? How do we calculate that? So if we start with L is equal to 5, meaning this patch, there's only one move we can do. We can only do a plus or minus 1 because there's nothing else. There's no other moves we can do. So if we do a plus or minus 1, how do we get to negative 3? Well, we have to subtract 3. How do we... okay, yeah. So if we subtract 3 from 0, 0, 0, 0, 0, then what happens to this patch? Well, it becomes a negative 6. And this one becomes a negative 9. And negative 12. Negative 15. This is just because the negative 3 is being amplified in this patch by 2. And then amplified by 3. Amplified by 4 times. So next, we're going to look at L is equal to 4. When L is equal to 4, then we can do a plus or minus 1 on this patch. And we need to get that to a 2. So in order to get from a negative 6 to a 2, we have to add 8. So if we add 8, we get 2. Add 16, because we're like having a magnitude of 2 in this patch. Then we'll get 7. Then we'll get 12, because we have to add 24. Then we have to add 32 here. So we'll get 17. Okay, next. The next plus or minus 1 comes from here. And I noticed these aren't aligned, so let me fix that real quick. Just for the sake of organization. Okay, like that. Alright, so the plus or minus 1 means we have an L of 3. And we're changing this patch now. So to get to 5, we have to subtract 2 here, which means we have to subtract 4 here, which means we have to subtract 6 here. Okay? Easy. From now on, I won't like box everything, but I'll still fill in the pyramid. So next up we have negative 7. So that's minus 15. So over here we have to minus 30 to get negative 19. And finally we have just a 1 here. So now we just worked backwards. We had we started with a little array, and then from there we went on to the next state, and then the next state, and then the next state. Okay, well, we can call this beginning state target array. And I'll let you know why. So for this first algorithm that I'm going to explain, it's very, very simple. So what we're doing is we're going to start with this target array. Then we're going to have 2 for loops. One's going to be inside the other. So we're going to have a nested for loop. And the outer for loop will go down like this. And then along the way, it'll construct the array. Then for the next iteration, it'll reconstruct it. Then it'll reconstruct it. Oops. Then it'll reconstruct it like that. And it'll always update the elements. Now this is because we can find the answer really easily using that method. The answer is just going to be negative 3 minus 0 and take the absolute value of that. So if we have negative 3 minus 0, that's 3. Then we find the difference between these two. Then the difference between these two, and finally these two. And keep in mind, we're going to take the absolute value of the difference. So if we have 3 in the first element, then we have 8 for this one. Then we have 2, 15, and finally 20. We will end up with, I believe, 48. Now that's the correct answer. So using this for loop method, we can constantly reconstruct the array and then based on that find the new distance between the current elements, these two elements, and then add that to our total. So keep in mind that this algorithm will run in O of n squared time complexity, and that's a little too slow to get full credit. In fact, I tried submitting it and then I only got 10 out of 15 test cases, so exactly 2/3 of them. But how it works is that we're going to store answer as the initial element. So we're setting it initially to positive 3. So that's this one. From there, we're going to start and loop over using an outer for loop. And then at every iteration, we're going to calculate a distance. And then the inner for loop, what it does is we use it to kind of reconstruct the new target array. And then we finally add the absolute value of that distance to answer. And then we can output that. So yeah, a little too slow, but now let's try to find a smarter way to solve this same problem. Okay, well, the answer, if you look at it, is literally just a sub I, or this number. So this is a sub I, so this corresponds here. This 2 corresponds to this one. 5 corresponds to here, and so on. But it's just the a sub I minus this number, this number, this number, and so on. We already know what a sub I is because that was given to us in the input. What we don't have are the numbers boxed in red. But how do we even find those numbers? Well, another thing we can use is the fact that we have target array. So since we have target array, all these red numbers are literally just target array plus a certain sum. Target array plus a certain sum will get you to 8. Target array, which is negative 15 here, plus a certain sum will get you to negative 19. And now we have to find that sum because we already have target array. So since we have target array, we can just say target array sub I plus a sum. So now we boiled down the problem to finding a sum. Now that sum is how we get from a target array, so negative 15. Oops, why did it do that? Okay. From negative 15 all the way to negative 19. Alright, let's write some stuff down. So let me just erase this little thing that we have here to make room. Okay. So how do we get from negative 9 to 7? Well, that's just plus 16. How do we get from negative 12 to 12? Plus 24. How do we get from negative 15 to 17? That's plus 32. Okay. How do we get from 12 to 8? That's minus 4. How do we get from 17 to 11? Minus 6. And finally, how do we get from 11 to negative 19? That is wait, am I, okay, yeah, that is minus 30. Yeah, minus 30. Okay. But how do we even find these numbers? So now we're one step closer, but how do we get how do we get 16? How do we get 24, 32, and all these numbers? Well, 16, and now I'll just type it out because it'll make it faster. 16 is just 2 times 2 minus negative 6. So all we're doing is we're taking the distance between 2 and negative 6, which are over here, and then times 2 because we're in this patch, and the magnitude is increased by 2. So now let me copy and paste this. For 24, it's something similar. It's, instead of 2, we have 3 because now we have a magnitude of 3. And then for 32, we have a magnitude of 4. Okay, for the next column, or next row, we have negative 4 because we do 2 times 5 minus 7. Yeah. And then we have 3 times 5 minus 7. And then over here we have 2 times negative 7 minus 8. Yeah. So that will give us negative 30. This will give us negative 6. And this will give us 32, and so on. So what is the pattern here? Well, the distance between this number, so 16 to 24, is plus 8. So we do a plus 8 in order to get here. The distance between 24 and 32 is another plus 8. The distance between negative 4 and negative 6 is minus 2. Well, something common happens. If we add 8 here, we will continue adding 8 until we reach the end. So if we had a lot more lines, so let's say we had numbers here, numbers here, numbers here, numbers here, and so on, we would continue adding 8 every single time. That will never stop. Same thing for negative 2. For all those numbers, we would continue to subtract 2. Alright, all this means is that we're going to have to keep track of the previous distance. So that means if the distance is 8, we're going to have to always keep track of 8. And since we add negative 2 as a distance, we're going to have to keep tracking negative 2. But then along the way, we're going to have to also add 2 times the current distance. So since the current distance is 8, we're going to have to keep track of 16. We're going to have to add negative 4 because that's 2 times the distance. And then once we're here in this column, we're going to have to add negative 30 because that's 2 times of negative 15. So now I'll show the code. This code that passes all 15 test cases is really similar to the first one, but instead of using a nested for loop, it uses only a single for loop. So this for loop, all it does is it stores answer as, or it constantly updates answer, and then it sets the new answer to the old answer plus the absolute value of a sub I minus the sum of target array sub I plus sum. Now, one of the hardest parts of this problem is actually knowing which one of these lines to kind of put first or how to order them. And that's really hard because you don't know when you should add the sum, when you should add to the variable add, and keep track of distance and all this. It gets pretty confusing. But if you just go through it with some test cases, kind of think through it, think about like what are the implications of putting a certain line somewhere, then it'll be a lot easier to solve. Okay, so to reiterate one more time, how this algorithm works is we're going to start working backwards. So instead of kind of starting from here and then working down, what we're doing is we're starting at the very end at 0, 0, 0, 0, 0, then we're going to the second to last state, then the third to last, then the fourth to last, until we get to the very beginning. And then along the way, we're going to keep track of all the sums and all the distances and what to add. And then based on that, we have a little formula that'll allow us to find the answer by just using a single for loop. So if you guys found this video helpful, please like, please share, please comment. If you have any questions, yes, feel free to comment. I will try to respond to any questions. And thanks for watching.